multiplying some of these radicals together. Let's start in the top left, the 2x and the 3x. Like, that's super basic. Like, we're not trying to trick you or anything on that one. How would you multiply 2x and 3x together? Okay, talk to me about how you did that.
Oh yeah, 3 times 2.
Okay. Okay, so you almost like rewrote the order so that you had your constants out front, then your variables behind, and we know 3 times 2 is 6, and x times x is x squared, right? Okay, so when we do the problem to the right of that, your 2 square root x and your 3 square root x, more or less the same concept. I'm going to take my numbers out front, multiply those together, just like I did in the first one. But now I've got square root of x times square root of x here. And what is square root of x times square root of x? Okay, you're saying square root of x to the second power, and you're saying x, same thing, right? Because if I have square root of x and that's squared, that's still going to be a x. So you just have 6x here.
Can you close out of my Microsoft Word that I have open?
Okay, so this is our goal today, is same concept. You're going to take your coefficients out front, multiply them together, take your radicals, and multiply those together as well. So let's jump down to this 3 square root 2 problem. So I'm going to take my, so many highlighter options. I am not that fancy. I am not that fancy. I do not have it set up. Beautiful. So beautiful. Okay. All right. So we've got our 3 times 2 out front. I'm going to take, wow, I don't like that. Square root 2 times square root of 6. And what is 2 times 6? 12. So I'm going to have 6 square root of 12 here. You are not done yet unless you have simplified that square root of 12 all the way down. This is going back to what you did Monday and Tuesday with those factor trees. So 12 can be 4 and 3. Anything else I can break down further? Yeah. Very good. 2 and 2. So if I have 2 times 2 times 3, that 2 gets kicked out front. So now what do I do with that 6 and the 2 that's now in front? Just multiplying. 6 times 2 is 12. So I get 12 square root of 3. Always ask yourself at the end, like, is there any other like perfect squares I can take out of it? You know, 3 that you can't, so you're done with your final answer. Fair? I'd like you to try the next one down here, this one, with your shoulder partner or group around you. I'd like you to go ahead and do this one together.
You don't understand it enough.
Okay, this is how far I've gotten, which is not very far. Tell me how you broke down. I'm assuming what you have is square root of 75. Anybody? How'd you break that down? Or is it good?
15.
You did 15 and 5? Yeah, I was hoping somebody would say 25 and 3. Does it matter which route you take? You're going to end up with the same thing anyway. Just because this was a 15 and 5, I'm going to just do 25 and 3. Because why not? So there's your 5 and your 5. So that 5 goes out front. So I'm left with 99 times 5 square root of 3. Very good. Times that, and you get 495 square root of 3. Questions so far? Okay, top right here, same concept, except now you have just a little bit extra because it's more of a distributive property situation. Taking that times your first term and times your second term. I feel like I am consistently saying, like, do one chunk at a time. Don't try and blob it all together. So I'm going to start with that first half, my 3 square root of 5 times 2 square root of 5. Okay, so I'm going to rewrite that as 3 times 2 and square root of 5 times square root of 5. 3 times 2 is 6. And square root of 5 times square root of 5 is 5. So I'm left with 6 times 5, which is 30. You've just simplified that whole first half. It's as broken down as it's going to be. So now you can start tackling that second half with the same process. I've got 3 times 5. And I've got square root 5 times square root of 3. 3 times 5 is, and then square root of 5 times square root of 3, that's not a good 3, is what? 15. Can you break down 15 any further? Okay, but it's 5 times, okay, I should have clarified. Can you break it down with a perfect square? No. Okay, so now you're left with 15 square root 15. And what's the relationship between those two? Addition, because you have your plus sign up here. Same concept, just a little more work. Questions, comments, concerns on that one? Good? Over here, good? Yeah? Do you want to try another one with shoulder partner? Go ahead and try this one. Last one on this page. Go for it. Are you guys done over here?
Yeah.
24 plus what? Is it just 24 plus 16? Square root. Can you add those two together? Can I add this one and this one together? No, because they don't have the same square root. Very good. Yeah, sorry to hear that. Okay. Fair question on the other side was, can I take my 24 and 16 and just add those together because there's plus sign, Mrs. Suter? Can't I add them together? Okay, what did you learn on Wednesday? Because why though? They're not this, they don't both have a square root 3. So you can't combine them. Yes, Jackson. Yes, that is okay. Okay, we are almost done. Final questions on the front. Flip your paper over. Your last one for today is finding the area of a rectangle. And how do you find the area of a rectangle? Length times width, or base times height, whatever you're rolling with. So if I know I'm taking length times width here, and you designate one of those sides, like if this is my length and this is my width, we're going to multiply those two together. This is not a time to get fancy on me and to not show work. And I'm going to do it in my head, Mrs. Suter. That is great if you could do that. You better be writing it out. 5 square root of 2 minus square root of 3. That whole thing is taken times square root of 5 plus 4 square root of 3. Now on the last page, we kind of did a progression up to the distributive property. But now I've got almost 2 times 2 in a sense. What does that remind us of, or how can I multiply all those things together? What's that method called? I heard it. What'd you say? You could FOIL it, right? Taking your first terms, your outside terms, your inside terms, and your...
We never use the word FOIL. What do we call it? Distribute it.
Same thing.
I don't teach you FOIL because it only works on a binomial times a binomial. So if you have like a binomial times a trinomial and all you remember is FOIL, you forget that middle term. So FOIL, it's used, it was probably used more when Mrs. Hoosier and I were in school, or when I was in school, but you're distributing, you're multiplying the first ones, the outside, the inside, the last.
Regardless, both talking about the same things, maybe just a little bit different for vocabulary. Okay, let's go ahead and I would encourage you to write all this out first instead of just trying to do the math right away. Like I take my first terms, 5 square root of 2 times square root of 5. Okay, then I'm going to take 5 square root of 2 times 4 square root of 3. Now this gets interesting when I try and do this square root of 3 times square root of 5. What can I not forget? Yeah, that minus sign out front. If you don't like that random negative side just hanging out, very good, put a 1. Look at you. -1 square root of 3 times 4 square root of 3. Now you've got all pieces. Again, I'd encourage you to take one chunk at a time, so I might start with these first ones. I've got 5, and then square root of 2 times square root of 5. So 5 square root of 10. Can you break 10 down into any more perfect squares? Okay, then move on to the next one. I've got 5 times 4, which is, and I've got square root of 2 times square root of 3, which is square root of 6. Can you take 6 and break it down into perfect squares? Okay, so you're good on that one. Move to the next one. I don't have anything to take -1 times. Square root of 3 times square root of 5 is negative. Yeah, very good. Square root of 15. And your last one, -1 times 4 is, and square root of 3 times square root of 3 is, what'd you say? Cohen, what'd you say? Square root of 9. What is square root of 9? So -4 times 3 is. Okay, now that you've got all 4 pieces, how do you write your final answer? Yeah, just combine them. There's nothing that you can add or subtract together. 5 square root of 10. This is positive, so plus 20 square root of 6. -1 square root of 15. And this is a negative, so minus 12. Questions, comments, concerns? Yeah. No. Okay, you are on to your Alex. I think it's 12 questions.